to calculate the potential evapotranspiration (PET), and this is widely used in a lot of things such as calculation of the SPEI, standardized precipitation evapotranspiration index, which is basically used for drought analysis, and the potential evapotranspiration is also used for irrigation research projects and stuff like that. So whatever you might need it for, well, today I'm going to be teaching you how to calculate this. So today we'll be calculating the potential evapotranspiration by using three different methods. One is the Thornthwaite method, which is basically an empirical method. And the second one is Hargreaves method, which is a temperature proxy radiation method, and the FAO method, which basically is which will be calculating the radiation. We'll be approximating the radiation entry or radiation input by using the temperature data. Whereas in the FAO 56 method, we will be requiring observed radiation values. Now, let's move into how we start with all of this. Don't worry, guys, if you do not have these data, just stick till the video proceeds and you'll see how we can use it in different ways. Now let's start with some data. Well, here I have the data file. I have the temperature data. Let me just select a station first. So I have the maximum and minimum data of a lot of stations here. I'll just be selecting one of the stations for sample. So first of all, you'll be needing yearly, monthly, and daily values of temperature for any station you're trying to observe. So just select the year, month, day, and the values. Control C. I'll be using this in my new file. So I'll just paste this here. Sorry, paste it. Um, paste it using just text. Also, you'll be needing the maximum temperature data. So for the same station, I have the data here. I'll be copying this and pasting it here. So this is basically the temperature maximum. I'll be naming it as Tmax, and this is temperature minimum. I'll be naming it as Tmin. Just put this all into a table of formats so that it'll be easier for me. Now what we'll be needing is not the daily values, guys. For the Thornthwaite evapotranspiration calculation, you'll give we'll be using RStudio. So I forgot we will be RStudio, and we'll be using RStudio for this. Function for this, and what I was trying to say is will not be calculating the daily evapotranspiration. We'll be calculating the monthly average evapotranspiration values in millimeters per. This you'll be since we have the daily values of temperature, we'll be required here, since this is not precipitation, we'll be using the average values of temperature. Mind how you select it, guys, because things will be easier if you follow the way I do it. Just put your cursor right here, right where mine is, and drag it so it'll select all of it at once. Control C and go back. My year starts year 1980 to 2017, so I'll just write a simple year, and from the second I'll just enter a simple formula. If the month value is equals to 1, this is the format in which you'll be requiring your data. THR and TH. Now we have the year, month, average monthly minimum temperature, average monthly maximum temperature. Now we'll since your data is ready for the Thornthwaite method, just open up your RStudio, and if you do not have RStudio, I'll be showing you some of the things that I stumbled upon on the internet. So there's this research paper I found, and this basically talks about how the standardized precipitation index, well, it talks about is the standardized precipitation evapotranspiration index different from the SPI, standardized precipitation index, and how sensitive is it to the different values of potential evapotranspiration that are fed during calculating it. And yeah, it has focused specifically on the different methods, PET methods, that are found to be used, and some of them are empirical method, temperature based method, some are radiation based methods, some are combination equations. So here's a small table, and here you can see that the Thornthwaite equation, or the model, or the Thornthwaite method, is an empirical method which basically uses just the minimum, just the mean temperature, not the minimum, just the mean temperature, and radiation is dependent on the T mean, and it basically is an empirical method to calculate the potential evapotranspiration, whereas the Hargreaves method is a temperature proxy radiation method in which you basically use the temperature data to approximate the radiation data. So you'll be needing minimum and maximum temperature in this case, and not the radiation data. You'll calculate that. Radiation will be calculated based on the difference between temperature maximum and temperature minimum. And similarly, there are other methods. We'll not be talking about this one nor this one. Yeah, we'll be talking about FAO56 method, which is an observed radiation method, and you need to feed in a lot of different data for this method, such as the mean temperature, the wind speed, the surface pressure, specific humidity, and yeah, well, this is the most highly accepted method is the FAO method. But and well, let's see, this paper also talks about how the SPEI index is highly in the conclusions part. You can see the SPI index is to a greater extent or degree is the most sensitive to PET radiation terms. So um, yeah, those formulas or methods which include the radiation term uh, are sorry guys, are basically more accurate. Well, if you want to read this paper, you can just search standardized precipitation index, sensitivity to potential evapotranspiration model by James H. Stagge, and well, you can find it in the internet. Now let's move into the RStudio part. Now, for RStudio, you'll be needing to install a package called SPEI. So if you haven't done it yet, just before that, if your RStudio is not opened up like this, go to File and create a new file or script, and you need to install a package. So type in install inst, open up this rounded brackets, open up the quotation marks, SPEI, mind the capital letters, guys, and type it in. Since my SPEI index is already sorry, SPEI package is already installed, so maybe it'll reinstall it, I don't know. But well, I guess it reinstalled it. Anyways, that is good to go. So just move into the packages and don't forget to activate this. Yeah. You'll be loading the SPEI package once you put a tick mark in the packages tab here. The packages. Now, now what you'll need to do is this file, which is in format right now, year, month, temperature min, temperature maximum, temperature average. You just need to save this file into wherever that is most accessible. So I'll just name it as ET file for now, just to save it in my desktop and save. Okay, yes. Okay. After that has been done in your RStudio is opened, I guess I just, sorry, what the fudge. Anyways, okay, don't mind that, guys. Now, in the environment tab over here, just go to import data set, and from Excel, go to browse and just import that file that you saved in your desktop in the desired format, in the required format. ED is the file. Just open it up, and just in case that your data has been saved in a different tab, such as different tab, then just try to select this sheet here. It's on the right. Okay. And import. After that has been done, now what we need to do is use this function thr and type in. You'll need to feed in the average temperature, latitude, and that is all the data that is required. So if you do not have the latitude data, Name of my file is ED, so I'll type in ED. After that, a dollar sign. Now the column in which the data that is needed is stored, that is the T average, comma, latitude I'll 18 is equals to my value is 28.7 F for now, and hit the enter. Sorry, I guess latitude is, I guess you're not be needing the quotation marks there. Okay, yeah, here it goes. So this single line of formula will basically calculate the evapotranspiration, potential evapotranspiration values for different months, the monthly values. And if you want to know more about how this package works, let's see. Go to SPI, go to you'll just find the syntax for the different functions you can use. We just used this one. Secondly, we'll be using the Hargreaves formula, I mean the function. And thirdly, we'll not be using this one exactly. We'll be using a different method for the FAO 56 one. So all the arguments that are used here, the details about those are given here, details, right? So Thornthwaite computes the monthly potential evapotranspiration according to Thornthwaite equation. It is the simplest of the three methods and can be used when only temperature data are available. So the values here, the values, a time series with the values of monthly potential or reference evapotranspiration in mm. So basically, the 12.569190 you are seeing here is the average monthly value for evapotranspiration in millimeters. So for the month of January, the average evapotranspiration is 12.57 millimeters for the first year. Since my data range starts from 1980 to all over 2017, I guess. Yeah, 2017. So I have, this is the first year, this is the second year, this is the third year, this is the fourth year, and so on. 29. What is all this now? It is not looking right. What is happening here, guys? Well, this should not be a problem in your case, but just in case it happens or comes to be, then maybe we'll just rerun this code one more time. Month of January, February, March, April, May, June, July, August, September, October, November, December. So these are basically the evapotranspiration values for the first year, second year, third year, fourth year, fifth year of your study period. And this is how you calculate the evapotranspiration by using Thornthwaite method. If you want to export this into an Excel file, you can just need to install another package, and that package will be right need to install it using install.packages and this name right here inside the quotation marks and after ticking this no, not that, sorry, write dot xlsx. And firstly you'll need to use you'll need a data. All what you'll need to do is store these data into a variable, control V. So I'll just store this into dh. Good. Now you will need to convert this into a data frame, and for that you will simply write maybe again data frame, just you can name any variable. What we'll be assigning here is data frame, of the variable you'll be using. So just dho and enter. Brackets, write the data frame name, that is df, comma, now you'll need a path. Now for this, let's say I want to store it in again and control, just put it put a quotation marks, control V, and don't forget to put in double backslashes here, guys. Double backslashes, sorry. And one more, I'll need to name the Excel file, so et. Cannot open two books of the same name. Okay. Okay, so these are the control C, control V. Now you can use this to generate charts and all sorts of things. I'll use another method for RA is not, it is required, guys. If you have latitude, it makes more sense. And the PRE stands for, what is the PRE? The optional numerical factor matrix or time series of monthly total precipitation. So if you have that as well, then you can use it. And if you don't, just leave it as blank. Now, let's see. Har name of the file that I'm using, guys. So um, right, data. I do not have the PRE, that is the precipitation data. I just have the latitude data, and that is 28.78. So here you have it, the Hargreaves potential evapotranspiration data. So if you want to export this into an Excel file as well, yes, just do as you did earlier. What you did was, yeah, this part, right? So first of all, sorry, we do not have one here, so yep. And now just export it as right xl and that is done. Hargreaves potential evapotranspiration values here. So just copy all of this, Control C, and paste it right here. Guys, there is one last method that I'm talking about, but apparently I cannot be using it because I do not have the values for all of this. So you can use the penman function as well, but you'll be needing the wind speed value for this, and if you do not have that, then you cannot use this because these are the others are not required, but you'll be needing wind speed compulsorily. So well, it's basically the same format as what I just did. So that is it for today, guys. Thank you. I hope you like this video and subscribe to the channel. And if there are any questions or any help I can provide you with, then please feel free to contact me. Thank you. I'll be ending this video now. Ta-da.